Hello.
Hello,
Hey, how are you?
I'm fine. How about you?
I'm good. I think I interviewed you, right? Like a couple of days ago.
Yes, I believe so.
Awesome, awesome. So, do you have any interviews coming up soon?
Currently, I don't have any, but I've just been applying and just preparing.
Okay, got you. Awesome. Then let's solve some problems today. We'll see if you have done this mm, or not. Have you done palindromic substrings?
Palindrome substrings. I
Yeah.
believe I've saw it before.
You do you want to solve it or no?
Yes, I can. Sure, that's fine.
Okay, let's do that. So you're given a string uh, s, and we want to find out find the number of palindromic substrings. The string has. What do I mean by that is like if your input is ABC, you have like ABC is not a palindrome, right? You have A is a palindrome, B is a palindrome, C is a palindrome. So the output is going to be 3. But again, example 2, if your input is going to be AAA, then your palindromes are going to be A, 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 and also AA and AAA, right?
Yes.
Yeah. So there are going to be 6 palindromes.
Okay. Can we always assume that the input will be valid? Maybe if there's like an empty string.
Yeah, assume that it is not empty.
So if we can assume that it's not empty,
Yeah.
then so can I write in line 14?
Yep.
So one thing I'm thinking about is my approach. So I was thinking about maybe we can use recursion. So basically we're gonna start from the first maybe like the first input in line 5. So
Mm-hmm.
we have ABC. So
Mm-hmm.
then from there we always check okay if A, because from right now we can check okay if the current index is taken out
Mm-hmm.
if it's equals, then we can always say okay, let's try and expand it a little bit further. To try and expand it a little bit further, then by expanding what I mean is that we have ABC, then we have I over here, and we have J over here as well. Then we check okay, it is a palindrome. So then we're going to do like a recursive function call to expand a little bit. So we have A and B, now recursive call. So we add it into our output. So whatever it returns if it's true as a palindrome. So if it's true, it's going to return 1. But if
Mm-hmm.
it's false, it's going to return none. It's not going to return none. It's going to return 0 because 0 maps to false and 1 maps to 1 true. So
Mm-hmm.
based on what that is, then you can try to expand a little bit more to
Mm-hmm.
A, B, C, and C. But if that
Mm-hmm.
doesn't return like true or false, then we can always okay, let's come back to A and B and let's expand B and C as well.
Mm-hmm.
So then we do that like in a recursive call to always
Got
check
you.
if it's a palindrome or not.
So what is the
But
time complexity and space complexity going to be for this?
so the time complexity is going to be exponential because it's going to depend on how many branches we created. So it's going to be O of 2 raised to the power of n, and that will be dependent on the branches we created. We're exploring it.
Can you give a title bound
And
on exponential? I don't think this is exponential. Exponential is, I mean, n power n or like n power something. I don't think this is exponential. This is still a polynomial.
so when I say exponential, I mean O of 2 raised to the power of n.
What is that? O of n raised to?
O of 2, so I have something like this.
Can you write it down? Yeah.
Yes. O of 2, so we have raised to the power of n. Where n is the depth of the branch, or is the depth of the tree that has been created. What we're
Are you
exploring
sure that it's going to be O of 2 power n?
it. Yes.
Then maybe I did not understand what you're saying. So you're saying for every I, you're going to check every j whether it is a palindrome or not, right?
Yes.
So your I goes from 0 to n, right?
I goes from 0 to n, where x, and n is the length, x.
Right? So for every I, your j goes from again 0 to n, right?
Yes.
And then for every palindrome, you're going to you have to check for every I and j. You have to check whether it is a palindrome or not, right?
Yes.
So this is also going to be worst case is going to be n, right? So like you have three levels that is going to be O of n cube, right?
So it's going to be O of n raised to the power of 3, yes. So for each of the x, O of n raised to the power of 3.
Right?
Yes, O of
Is
n
that
raised to the power of 3.
yeah? So n cube is not exponential; it's a polynomial. N cube is less than 2 power n. So okay, can we do any better than that?
The other approach I can think about is to use, so maybe approach 2.
Mm-hmm.
You can try to use dynamic programming.
Mm-hmm.
So dynamic programming. So basically with dynamic programming, what we want to do is you can start from the beginning and always try to expand. So we can always expand both left and right and see if, because one fact we can notice from this question is that from the first line 5, we have A is always a palindrome, B is always a palindrome, and C is always a palindrome as in line 7. So we can always expand from wherever our A is and from wherever our B is and try to expand and see how long we can actually form a palindrome.
Mm-hmm.
And from
Can you write that down? Whatever you're saying.
so you can start. So you can start from the first index
Mm-hmm.
and get a second loop. So and use the second loop. So we have two for loops, two for loops. So the second loop, we expand. We expand from the current center, and try to see if we can expand all the way to the end on both left and right sizes. So we can so from the current and try to expand. depending on how long we can go. So we can go. So based on this, so if we can go far to the end of the input array, then we can always know for FAANG. Now we create this as this length of palindrome. Then we always go, maybe we have this AAA as an example. So we have AAA. The first one to do, we get our A, the first A. Then we try to expand from it. So we come to the second A. Then when we come to the second A, we see that okay, it is still the same, but however, so we have two pointers actually, one we're going to the left and one we're going to the right. So we have I and J for now. So from the beginning, this I pointer will go to the left side, and this will expand to the left to the right side. So this I pointer will go out of bounds, while this J pointer will point to the second A. So from there, we can okay, this is the length of the palindrome we've currently found, and we can always increment our size by that, by the length.
Okay. So it's a little difficult for me to understand. So like, do you want to go ahead and code it? You're good with this approach? Or before that, like, let me ask, like, what is the time complexity going to be with this?
So the time complexity is going to be O of n squared,
Okay.
O of n squared, and the space complexity is going to be constant.
Space complexity is going to be constant.
Yes.
So you're not going to populate dynamic GP table?
No, we don't need to actually.
Okay. Let's do one thing. Like, why don't we go ahead and code this up, and we can problem solve while we code.
Okay.
Awesome.
So I will just can I leave it in plain text or want me to change programming language?
Okay.
I can just change it to Python 3. So I'll start from line 47, 42.
Okay.
So basically, I want to create a function.
Mm-hmm.
We have palindrome substring. So in this palindrome structure, we have our strings. So we can have our string. So we can have our string. This is string x. Okay. So one thing I want to check is okay. If the string is empty, so we can string and just return 0. This is poly substring. Cost of 0, then just return poly substring. Okay, so from this we done this too. So from this place, we want to go through the string. So just okay for you can say for indexing range. Enter our string x. So now we're going through it. So one thing I want to do from that, because we can have either even length or odd length of string. So just okay, maybe the even length. Let me say the even length first. So from we can just say okay, value substring. So I'll create this new function separately. So get even substring. Yeah. So we can put the index in there. Then we can pass the index once again. Then from this place, so after putting the index and the next index, then one thing I want to do, I think this should be fine. So we need one more thing because we need to be creating a different string. So we can use the string s. Then when we have this, then we can create value substring again. But this will be for the odd length. So we have palette substring equal to grab get. Let me say get substring. So we have get substring, so we can pass a string x to then the index plus 1. So we have these two. Then at the end, we can just return palette substring. Yes, so we have this. So now let me just create a function. So I can create a function separately. So let's create a function over here. So we can have get. So this substring, this get substring is going to be expandable inward and outward. So we can have strings. Let's say string. String. Then we can have our start and our end. Okay. So we'll say total length equals to 0. So what I'm doing is okay, wow. So what start is less than end. Actually, we can do this actually, and that won't work. So what I want to do is just okay, what start is greater than equals to 0, and end is less than length of a string x. So we have this. So let's go if string x over start, so it does not equals to string x over end. So if that's not the case, what I want to do is just return total length. But else if that's not the case, so we just want to click total length is equals to 1. And you can decrement our starts, so minus equals to 1. And increment our end, is equals to 1. Then at the end, let's return a total length. Let's return a total length at the end. Then so palette substring. So we have palette substring B. Palette substring the even length and odd length X. So can I work with an example on this?
Yeah, let's do it.
So we have A, B, C. So basically we have A, B, C. So in line 43 is going to be 0. The palette substring is going to be 0. Then in line 44, it's not going to go through this line 45 because it is not empty. We have ABC. So in line 48, so the length, right? The length. So length is 3. ABC length is 3. So now we're going to, so our index is going to be 0. The index. So in line 51, so we have our index is going to be 0 and 0. So we have 0, 0. That will be the two indices. Then we call this function the get substring function. Then we come to this. Then we come to this line 59. So line 59, our start. I can just say st to the start equals to 0. Then ed equals to 0 because that is the start and end. So then line 61 total is 0 for now. So we say okay, y start is greater than or equals to 0, which is true because our st is greater than or equals to 0 in line 59. And our end as well is less than length of the string, which is 3, is less than it. So then we come to line 55. Then we check, okay, if string of start, which is A, does not equal to string of end, which is A. that's not the case, so it's not going to return total length. So it's going to come to line 67. So our total length now will be 1. Then our start now be equals to -1. Then the end as well will be equals to 1. So we're going to go back to the while loop, line 63. Then we'll check does our start greater than equals to 0, which is true, because now our start is -1, so it's not going to go through this while loop again. So it's going to return total length. So line 51, our palindrome now is going to be 1. So now we have our palindrome to be 1. So for now our palindrome is 1. So I can just, let me just put it over here. So we got palindrome now equals to 1. So we don't need this over here for now. So now we're going to go to the next index in line 48. So now our index will be 1. Then in line, now we don't even need to go there yet because now we're still in 0. So we'll come to line 55 actually. Then we call the same function on our index and index plus 1. So our index will be 0 and 1. Then we come to, then after calling this function, we come to line 60. So our start will be 0 and our end will be 1. So the total length for now is 0. Then we say, okay, what start is greater than equals to 0 and end is less than length of string, which is true because start is 0 and the end is 1, which is true. So in line 66, we're going to check, okay, string of start, which is A, does it equal string of end, which is B? It does not equal because A does not equal to B. So we're going to return total length, which is 0. So now our palette substring will be still 1 as line 43. Then we're going to increment our index in line 48, so our index will be 1. Then we come to line 51. Then we say, okay, now our index is 1 and 1. So then we call this function, we call this get substring function.
Can we do one thing? Like, can we run the test cases that I've given you?
Yes.
Yeah, I think I understood what you're doing. Let's run the test cases that I've given, and then maybe we'll run more. But yeah, let's run the test cases that I gave you.
So substring. We have A, B, C. Yeah, this is the test case, A, B, C. Then the other one. Let's copy this. This will be A, E. Okay. So let me run.
Awesome.
3 and 6.
Awesome. So yeah, let's do another problem which is similar to this. Let's find what is the maximum substring palindrome or longest substring palindrome.
So one way we can try to find the longest substring palindrome is to do it this way. So over here, when we return, we can use the same function and just adding it. We don't need to add it, so we can just get this palindrome. So can I write in line 51?
Well, yeah.
So we can have palindrome 1. We have our palindrome 1 to be equals to this for now. Then we have our palindrome 2 to be equals to this for now. So at the end of this, we can just get a max. So, but actually, before we get a max, because at this place, at this index, this 2 index is going to break out when it is out of the loop. So we want to do one thing, before we do that. So over here, yes. So yes, we can do it this place. So what you want to do for me is just okay. I can just say mass palindrome equals to max of mass palindrome and poly1. So we have palindrome substring minus substring 2. So we're going to get the absolute value of it. Then over here, so other than having this palindrome substring, you don't need palindrome substring actually. You can just get mass palindrome. And just say to be float negative infinity for now. Because the first time we come out of these two loops, we're going to have it. So over here, what we want to do from here, if we have does not equal to this, rather than just return it from here, we don't want to return. What we will do from here is just okay. Just return end, right, minus start.
No, we want to return the string itself, longest palindromic substring.
So we want to return the string itself. Okay.
Yeah.
Okay.
Whatever is the longest palindrome, we want to return the string, not the length.
Okay. So let me think through. So we don't need line 58 then. Yeah, so if we want to return the length, yeah, we can just return true from here, right? We can return false actually, because just return. Then over here we don't need this anymore. So we can just do something from this place. So we probably don't need this. So because this index is the midpoint. That's the midpoint of how it can expand both left and right. So rather than having these two index, I don't want this two index. So one thing I can do for me is to think through this.
So at line 77, are you going to return start and end?
No, I'm going to fix that. I'm still going to fix that as well.
Okay,
I'll fix
got
that
you.
as well. I'm just working on line 58. So from this, so we have this starting index, right, which is this. Then we have the end index, which is that. So because we want to okay, I see. So from here we have this. Then from this place, what we want to do, because now we are the middle. So if you are the middle, you can just get it minus half of this, because by this time this have gone to half and this would have gone to half. So I've gone forward by half and this would have gone left by half in 952. So I can just return half of this. That means this current index minus the half of it. That will give me the left side by half. While on this, I can just return this index plus half of it. So what I'm saying is that so I can do it this way. So I have this, then one thing I'll do from here is to say let me do this way. So I can have left side equals to index, right, minus index divided by 2. Because this will give me the left half. And my right side will give me index, right, plus this current index where I am divided by 2 as well. Then when I have this, so what I have to do from this is okay. So I just okay if my right side minus my left side minus left side. So if this is greater than mass palindrome, so then what I want to do for me is okay. Let me do this. Let me say max length. The mass palindrome will now be equals to string of my left side to my right side plus 1. So that means the last index plus 1. Then from the okay, mass length will be equals to right side minus left side. Then over here we don't need this anymore. So then one thing I have to do from here is to say, okay, let me initialize my mass length. So we probably don't need then this is just equals to an empty string for now. The mass length, let's initialize mass length to the float infinity. Then over here, so we can have this. Then this place we can just return max palindrome. Okay. So over here, so one thing we want to do for me is that we don't want to return total length anymore because we don't need total length. We can just return. Then we don't need total length as well anymore. And so we don't need length 75 as well anymore. X. Then we can move this. So we can move this upward and hello?
Hello? Yeah, I'm here.
Okay. So we can move this upward and circle. But we probably don't need this. What's that?
Yeah, like you still need to return something here, right? On line 77.
Yeah, that's why I return. So basically, that's after we've gone through the whole loop. So I mean, no. So what we can return from this place, so we can return our end minus our start. So because now we've gone through, we've extended out of both loops. So then that'll be a minus start minus 1. Let me go through one example to see. So we have A, B. So let me assume that we have I. So now it's expand by 1, comes to this place, then J, so this J at B. So we have I.
You can try running it. If you want to check, you can debug by running it, running the functions.
Okay. So this return BA, but shouldn't return BA, it should return, no, shouldn't return BA. It should return A only and not BA.
Yep.
because A, B, and C, they are palindromes of one length each.
Yep.
So,
So like, see, what you're doing here is you're taking the IDX and then this is not doing anything, right? Here. So you're just running this. I mean, like you're not using it here and anywhere. Does that
can I
make
see what
sense?
the cost is?
So you're running this function, you're getting something from here, but you're not using it here at all.
Where is the
You
function
might.
at?
What is that?
What is your cursor at?
I'm not able to understand you.
I mean, where you pointing to? What line?
The line 53.
Line 63.
So you're running line 53 and 55, but how are you using poly substring 1, poly substring 2?
I see. So, okay, I got it. I got it. Yes. So one thing I want to do from here. So one thing I want to do from here is to say, do this way actually. So I can add it to the, maybe I can call this to the length, the even length, or let me say even length. Let me call this to the odd length. So when I add the even length and the odd length, so I need to use it. So I need to get a max of each of them. I need to get a max. So one way I can get a max of each of them is okay. The max length is equals to max of even length and odd length. So now I have the max length. So from this place, so I don't even want to do this now. I want to check first if if the max length, right? If the max length is greater than the current max is greater than what I currently have.
Mm-hmm.
Let me see. If my current max length is greater than what I currently have, now this is I want to do something. So
Mm-hmm.
over here, so if it's greater than it, does want to do something. But I have my current max length with this, so I don't need this. Actually, I don't need this. I will comment this part out because I don't think I needed this now. Okay. So if my current max length is greater than this, so what I have to do is this, okay. My left right equals to my current max length because my current max length is the total length. So I have to get it from the midpoint backward and from the midpoint forward. So I say current mass length, right, minus current mass length, right, divided by 2. So this will give me backwards. Then the right will be current mass length, right, plus if this give me backwards, right? So if you give me backwards, yes. So there's a current mass length plus current mass length divided by 2 as well. Okay, so I have this. So I can just say mass palindrome DORM DROME is equals to our string X, right, from the left, right, to my right, and to my right inclusive. So that will be plus 1 because it's inclusive. And my max length be equals to current mass length. Yes.
Okay.
So
Let's run this.
oh, I see. Hmm. one thing I want to consider doing is, yes, I think I know what is going on. I know what's going on. Because over here it is non-type, so it's returning none. So that's the issue. So I want to do this way. Let me just do something else.
So you want to return 0 here instead?
No, I won't return 0 because even it may be inside the for loop, it may still be going inside the while loop and going forward as well. So I don't want to return 0.
Okay.
I believe it's gonna work now. And does not equals to this. And this equals to this. So as long as they're equal, declare my start, include my end. And keep
Mm-hmm.
going that way. But when it does not equals anymore, I know that I can just return my end minus start minus 1. Because now both of them will be out of bounds, so I can just return it.
Okay.
Difference x. Yes, and this. B and A. So the first one, I said the first one should return B, and the second one should return A triple A's.
So why don't you return end and start here rather than the length itself, and then you figure out instead of doing this calculation. I think this is messing it up. Uh, so if you return end and start, and then you can use to see if that is which one is bigger, and then directly get your left and right. Does that make sense?
Yes. So finish return end, comma start. So I have this. So when I return this, so then I can just have.
You might have to return end minus 1 and start plus 1, right?
But if I return n minus 1, so now it won't be inside the range anymore.
So here, like, whenever you do, your loop is going to exit with end plus 1 and start minus 1. So you will have to return end minus 1 and start plus 1, right?
Yes.
Okay, gotcha. Yeah, and then you can do, yeah, left comma
Left. So left comma right.
or right comma left. Is it right comma left or left comma right? Because you're returning end and start.
That's fine.
Yeah, awesome.
So I have both of these. So I can just put in 1 and 1. Right. Then put this to be. So let me just copy this. Of right side 2 and left side 2. Alright. So we have this. So when we have this now, we have both of this. So what we want to get from this is to get the max length. So we can have, okay. So I don't need this.
Yeah.
So right here, I can just say, well, even length, right?
Mhm.
Even length will not be, let me comment it. Even length will not be equal to right side 1 minus left side 1. Alright, so I have this for my even length. And I say odd length. And I go right side 1 minus left side.
2, right?
So now I have both of this. I have this 2. So one thing I want to do for me is okay. So I say if, let's do this, if even length is greater than
Yeah.
odd length. So if it's greater than odd length, I know that okay, my current max length will be equals to even length. Then I want to do something from here. Let me create a boolean, so let me create a flag. Check equals to false for now. So we probably don't need this for now. Then true. Okay. So one thing is else prime mass length equals to odd length. Okay, now we have these two. So what I do for me that I don't okay, if our current mass length is greater than mass length, right? So from here I'll say okay, if check, right? So if the check is true, now I know that I'm dealing with my even length. So just okay, let me just so we probably don't need this for now.
Yep.
We don't need this for now. So then over here, okay. So we're gonna get our string, right? So we start from our left side one, because now I'm dealing with my even the left side one, right? To my right side one, right side one plus one, because I'm trying to get the last index, right?
Yep.
So else, but else if that's not the case, so if does this check else? So if my check is not true, then I can just do this. So, but now when I do this, so I'm gonna do it with 2 and 2.
Awesome. Let's
Then
try this.
mass length is still the same. Okay.
Awesome.
Yeah.
Yeah. Good, man. Yeah. I think I have similar feedback to what I had last time. That is, you're good at the problem solving and coding it up, but I think you should figure out a way where you can communicate um, in a better way. What I mean is like um, you need to write down as much as you can and explain your thought process in writing down uh, whatever you are thinking through your head.
Okay.
Yeah, that is, you need to still practice on that a lot more, I would say. At the end of the day, it is like, yeah, one thing is, one thing you need to solve the problem. That is for sure. You'll have to do it. And then there is like the other things that are like, whether are you clear in your communication? Mm, are you if you're not clear, I mean, like, not everybody is good at communication, and I mean, like, we don't have to take that as a bad way, but you can find a way where you can communicate. For your case, you need to find a way or figure out a way where you can communicate better to your interviewer, like writing down whatever your thought, thinking through, or some form, like if you can do like go to drawing mode, do the drawing to tell them like what you're thinking through. uh, that will give you like even better points um, than not doing that at all. So you try to do this here, but I would do even more. Like I would write down a lot more. So when you're doing this, I would write down the recursion here. What is the recursion that you're going to do? Quickly write down the recursion, and then here, like, quickly write down the pseudocode to tell them what you're thinking, or some way, like, not just use the examples that I gave, or use some complicated examples, or like if you're expanding from the center, like how are you expanding from the center, sort of stuff. Like I would try to explain that even more. Uh, for me, it was difficult to understand the approach to a little bit. So that's why I asked you to go ahead and code it. But when you're coding, I got that. So if you could avoid that thing, that'll be really good. But I think really great job today. Like you've done much better than last time.
Thank you. Yeah. I mean that's why I'm practicing as well.
Okay.
because of the communication. Because they have been told that like a couple of times, so that's why I'm kind of practicing to improve on it.
Yeah. So there is nothing wrong. I'm not saying that you're wrong, but I would say like do not try to change who you are. Try to communicate better. Like try to write down things. You can use other media. Like you have technology to use. Use technology to communicate better. That's what I meant.
Okay.
Okay. Awesome, man. Good job today. Have a good rest of your day and weekend.
Thank you. You too. Thanks.
Bye bye.